Hi, I'm Melissa Ragazzino, and I'm from Lab Section 02, and this is Video Lab Report 6.
So now we're going to talk about the balanced chemical equation for our experiment for the neutralization reaction performed. So first we start with citric acid, which is C3H5O, COOH, 3 aqueous, plus 3 moles of NaOH, aqueous, which is sodium hydroxide, and which yields, I'll move down here, Na3C3H5O, COO3 aqueous, which is sodium citrate, plus 3 moles of H2O, or water, liquid. So now we are going to show a calculation, sample stoichiometry calculation using the experimental NaOH titron volume to calculate the concentration of citric acid in the titrated sample. So first we started with 19.00 mLs of NaOH. So first we convert this to liters. And we get 0.019 liters NaOH. So we take this number, and along with the molarity that was given to us at 0.0813, and we plug it in. So liters go at the bottom, and we're looking for moles here, so that'll be our X. We're going to cross multiply. So we do 0.0813 times 0.019. And we get 0.0015447 mole NaOH. So we're looking for citric acid, so we have to convert this to moles of citric acid. So then we're going to do 0.0015447 mole NaOH. And for our balanced equation, we had 3 moles of NaOH, 1 mole of citric acid, so when you do that, you get 0.000 mole of citric acid. So then we take that number and we plug it in to find the concentration. So we started with, so M equals, we started with 2.00 milliliters. So we have to make that liters as well. So now that we did that, we will use that and plug it into the molarity equation. So M equals, our moles is 0. over 0.002, and the molarity for trial 1, the citric concentration, is going to be 0.25745, but for significant figures, 0.2575. And that is the molarity or the citric concentration of citric acid in the titrated sample. The average citric acid concentration from our 3 titration trials. So like we did in the last round, we did the stoichiometry, and that's how we got this number for trial 1. So I actually did the same thing for trial 2 and 3. I just didn't do the math on camera. But I'm going to show you just how we get the average molarity of them. So we're just going to add them all up. And we get 0.674. So then we divide by 3 to get the average. You add them all and then divide by the number of numbers. And we get 0.2558. So that is the average molarity for 3 trials in the experiment. Okay, so now we're going to compare the average pH value for the lemon juice sample before and after titration. So the pH was calculated by using the machine and sticking it in the juice and then reading the pH off the measurement. So what we do here is for our trials, so before titration, these were the numbers that we had. So our average for before was 2.71 pH. And then after was going to be 9. Was 9.0433. So obviously you can see the neutralization really changed the concentration. This actually became more of a base, whereas this was an acid to start. And this can cause by adding or repeating the titration cycle, it can cause the pH to go up, as we can see here. Lastly, we're just going to cite our references. So our only reference for this experiment was the lab manual, J. Booth, D. Jean, L. Santoro, S. Siucidis, E. Schaub, and it's the Chemistry 110N Foundations of Chemistry Laboratory Manual. It's at the University of Mount Union, Alliance, Ohio, 2019, and it's pages 46 and 47. Yep, that's it.